All right, now we can't do a whole lot of studying reactions of aldehydes and ketones until we can name them. And so we saw formaldehyde and we saw acetone, but you have to learn the steps to naming aldehydes and ketones systematically. Plus, we're going to look at some common names as well. But when it comes to naming aldehydes and ketones, it's going to be the same procedure that we saw with alkenes, alkynes, alcohols, etc. The first thing we're going to do is we're going to find the longest parent chain that contains our functional group. We want to give the functional group the lowest number possible. We want to identify and name the substituents, so 2, 3, dimethyl, etc. Right? We want to give a locant, which is just a fancy word for a number, to each substituent. And then you put the name together alphabetically. Okay, so ethyl comes before methyl, right? Bromo comes before chloro, etc., etc. Same old rules that we see all the time. Just one thing I would add to this is that when you're working with aldehydes, when you're trying to name aldehydes, is that the carbonyl carbon of an aldehyde is always going to be carbon number 1, right? If you think about it, it doesn't matter how many, right? The carbonyl carbon always has to be number 1 because you want to give the functional group the lowest possible number. Well, if it's an aldehyde, then it has to be carbon number 1 has to be the carbonyl carbon because on this side we have a hydrogen attached to it. All right, so let's go through the rules. First one, if you have an alkane, remember that the suffix is E, so if you have 4 carbons, that's butane. And so if you replace that carbon with a carbonyl, it becomes an aldehyde, and so it would become butanal, okay? Now, we don't have to call this 1-butanal, right? That would be redundant because remember, the carbonyl carbon is on the first carbon, okay? So that's the way it always works with an aldehyde. Now, if you look at the example down here, you see that in this alkane, the longest carbon chain are these 8 carbons, which is octane, and we still have these 8 carbons in a row here in this molecule, but the carbonyl is not part of that chain, and so that wouldn't be considered the parent chain. Remember, the parent chain has to contain the functional groups, or the functional group rather, and so we have 1, 2, 3, 4, 5, 6, so this would be a hexanal, and again, you don't have to call it 1-hexanal. That would be redundant. With an aldehyde, the carbonyl carbon is always going to be the first one, carbon 1. Now, something else that's interesting about aldehydes and ketones is that the aldehydic carbon or the ketone carbon is always going to take priority over a hydroxyl or a double bond. I repeat, if you have multiple functional groups, meaning an aldehyde or a ketone, and then a hydroxyl group or maybe a double bond, the aldehyde or ketone will always take priority over those. And so if you look at this compound, you might ask yourself, well, I have a hydroxyl, I've got an alkene, I've got an aldehyde, where do I start? Well, you have to remember the rule that the aldehyde carbon is going to be assigned number 1. And so the way that it's shown here, starting with the 1 on this carbon of the double bond would be incorrect. Now, if aldehydes end in al, what do you think ketones end in? Well, they end in -one. Okay, so if we have butane, and then we replace one of the central carbons with a ketone or a carbonyl, it becomes butanone. Now keep in mind in this specific case, we have 1, 2, 3, 4 carbons, but we don't have to call it 2-butanone because the only place the carbonyl could be would be on carbon number 2, right? If it was over here, you'd number from this side 1, 2, 3, 4. And if it was on carbons 1 or 4, it would be an aldehyde in that case, okay? It's not till you get to 5 carbons that you have to start using a locant. Like let's say you had 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, like this. If you put a carbonyl here or here, these are 2 different ketones, right? This one would be 2-pentanone, and this one would be 3-pentanone, okay? So you don't have to start using a locant for your carbonyl of a ketone until you get to 5 carbons. All right, now something else that's interesting about naming ketones is that the locant for the carbonyl can come either before the parent or it can come before the suffix. Either one is totally fine. So with both of these compounds, I could have called them 2-pentanone and 3-pentanone, or I could call them pentan-2-one or pentan-3-one, and you see that exemplified down here with this compound. You can call it 3-heptanone or heptan-3-one. And if you're wondering, well, why would you have 2 different ways of doing it? It doesn't really become abundantly clear until you start naming compounds that have multiple functional groups in them. But for now, you just need to know that both ways are acceptable. Now, if you have a chiral center in your molecule, you can't leave that out, right? And you can see we have a chiral center right here in this molecule. it has an R stereochemistry, and so we have to include that at the beginning of the name. Now in this compound, the longest carbon chain that contains our aldehyde has 1, 2, 3 carbons, so this is some kind of propanal. Then we have a phenyl at carbon number, we have a phenyl, at carbon number 3. Okay, so that's attached to this carbon here, so it's a, and then we've got a chlorine at carbon 2, so 2-chloro, 3-phenyl propanal, and of course you include your stereochemistry. Another one that's kind of interesting is a carbaldehyde. So if you have your aldehyde attached to a cyclohexyl group, or cycloalkyl group, I should have said. In this case, it happens to be a cyclohexyl specifically. In that case, you name the cycloalkyl group first, and then it's followed by carbaldehyde. Kind of a weird word, okay? But you name the ring, and then you put carbaldehyde. So this is cyclohexane carbaldehyde. So let's say you had something like this, okay? That would be, this molecule would be cyclobutane carbaldehyde. So carbaldehydes. And I told you have to memorize a few common names for aldehydes. If you have one carbon in your aldehyde, you could call it methanal, but the common name is formaldehyde. If you have 2 carbons, you could call it ethanal, but the common name is acetaldehyde. And benzaldehyde, you would have seen that in the chapter on aromatic chemistry, and you have to memorize that name. Now this is a table that I took from another textbook, but I think it's wise for you to memorize the common names of the first 5 aldehydes. Okay, so starting with 1 carbon and then 2 carbons, 3, 4, and 5 carbons respectively. Okay, you should know the systematic name, which is the IUPAC name. Sometimes I call it systematic, okay? And then common name as well. The reason I call systematic or IUPAC systematic is because common names are also accepted by IUPAC. But for our aldehydes, okay, if we have 1 carbon, it's going to be methanal. The common name is formaldehyde. If we have 2 carbons, you can call it ethanal. That would be systematic. But it's also more commonly called acetaldehyde. Now here's one that's kind of interesting. Propanal, right? Think methanal, ethanal, propanal. But the common name is propionaldehyde, which is kind of strange. Then from butanal, you go to butyraldehyde. And then the last one, pentanal, is called valoraldehyde, which is way off in left field. But these common names show up a lot in organic chemistry. So that's, you can imagine, if I went and took a table from another textbook and popped it in here, I must have thought it was pertinent. And I think that these are relevant for my students. So let's see if we can come up with some systematic names for these compounds. The first one's an aldehyde. We have 1, 2, 3, 4, 5, 6. So this is some kind of hexanal. We have a 2,2-dimethyl. We have a 5,5-dibromo. Bromo is going to come first because B comes before M in the alphabet. So this will be 5,5-dibromo, 2,2-dimethyl hexanal, like that. So 2,2-dimethyl hexanal. The next one, we have 2 stereocenters in this one. I'll highlight them here in yellow. They're both R. I went and looked at them ahead of time, and they both have the R stereochemical configuration. So this one's a ketone. If we number, giving the carbonyl the lowest possible number, which would be 2. 1, 2, 3, 4, 5, 6. So this is a 3, 4, 5 trimethyl. So this would be 3, 4, 5 trimethyl, and it would be a 2-hexanal. So 2-hexanone, 2-hexanone, or you could call it hexan-2-one. Either way is fine. And we have to include the stereochemistry at carbons 3 and 4. So like I told you, they're both R. And so we'll just put in here in brackets 3R, 4R. There you have it. All right, the next one, or the last one, is a cyclopentanone, is what this would be, right? There's 5 carbons in the ring. And so the carbonyl carbon is going to be number 1. So we have 1, 2, 3, 4, 5. So this would be 2,2,5,5 tetramethyl. So 2,2,5,5 tetramethyl cyclopentanone. So cyclopentanone. And this next question here, I didn't go over this in the body of the video, but I think you should know how to name a diketone or even a triketone. And if you have 2 carbonyls, we call that a dione. And if you have 3, we call that a trione. And you can see an example is shown here. The longest carbon chain, 1, 2, 3, 4. So this would be 2,3-butane dione. And so if you had this molecule here, you have 1, 2, 3, 4, 5, 6. So this is a cyclohexane. So this would be 1,4-cyclohexane dione. So 1,4-cyclohexane dione. And the next one is a trione. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. It wouldn't matter which side we started numbering from because you can see there's symmetry in this molecule. So this would be a 2, 5, 8. So 2, 5, 8. And then it would be nonane trione. Nonane trione. So now you know how to name a dione and a trione.